So the next problem is in composite sections. So steel rod is in center, which is surrounded by copper tube. Okay, see, let us go to the problem. A steel rod of 3 centimeter diameter is enclosed centrally in a hollow copper tube of external diameter 5 centimeter and internal diameter 4 centimeter. The composite bar is then subjected to an axial pull of 45,000 Newton. If the length of each bar is equal to 15 centimeter, determine the stresses in the rod and tube and 2 load carried by each bar. Take capital E for steel as 2.1 into 10 power 5 Newton per millimeter squared, and for copper 1.1 into 10 power 5 Newton per millimeter squared. So in this problem, the diameter of steel rod equal to 3 centimeter, that is 300 mm. Then area of steel rod 30 mm means pi d squared by 4, pi into 30 squared by 4, which is 706.86 millimeter squared. Then external diameter of copper tube, which is 5 centimeter, that is 50 mm, and internal diameter 4 centimeter, which is 40 mm. Therefore area of copper tube, which is hollow tube, no, therefore pi by 4 into capital D squared minus small d squared, that is 50 squared minus 40 squared into pi divided by 4, which is 706.86 millimeter squared. Now the axial load on composite bar totally P equal to 45,000 Newton. This is total load. Then length of each bar, length equal to 15 centimeter, which is 150 mm. Then Young's modulus for steel rod is 2.1 into 10 power 5 Newton per millimeter squared, and Young's modulus for copper is 1.1 into 10 power 5 Newton per millimeter squared. So the first question is the stresses in the rod and tube. Okay, now see here, the load which is totally acted on the composite bar, therefore the strain in steel rod equal to strain in copper tube. So strain E of copper equal to E of steel. So E is nothing but, you know that this stress by Young's modulus equal to strain. So sigma S by ES equal to sigma C by EC. So we equate it and we find out the sigma S equal to sigma C, but we want to find out either sigma S or sigma C. Okay, then only we can derive further. So sigma S equal to, ES by EC into sigma C. So the values of ES and EC we already known, Young's modulus values, that is 2.1 into 10 power 5 divided by 1.1 into 10 power 5 into sigma C. So sigma S equal to 1.09 sigma C. You know that stress equal to load by area, then load equal to stress into area. So load on steel plus load on copper equal to total load, that is P equal to PS plus PC. Okay, so that load is stress into area. So sigma S into AS plus sigma C into AC, that is equal to total load. So now sigma S equal to 1.09 sigma C into that area plus we don't know sigma C value. So sigma C into that area of copper tube. So now we want to find out only one unknown, that is stress in the copper tube sigma C. So sigma C we have to find out by resolving this equation then sigma c equal to 21.88 Newton per millimeter squared. Now substitute the value of sigma c, okay, then we find out sigma s, because sigma s equal to 1.09 sigma c. So from that we can get the sigma s value, that is 41.77 Newton per millimeter square. So the next question is load carried by each bar. So you know that the total load P equal to PS plus PC. Now PS equal to sigma S into AS. So you know that values, then you find out the load which acted at steel rod. Similarly for copper tubes, from total load minus the load which acted at steel rod, then you can get the load which acted at copper tube. So the next problem, temperature stresses in bars, composite bars. Let us going directly to the problem. A steel rod of 20 mm diameter passes centrally through a copper tube of 50 mm external diameter and 40 mm internal diameter. The tube is closed at each end by rigid plates of negligible thickness. The nuts are tightened lightly home on the projecting parts of the rod. If the temperature of the assembly is raised by 50 degrees Celsius, calculate the stresses developed in copper and steel. Take E for steel and copper as 200 giganewton per meter squared and 100 giganewton per meter squared, and alpha, that is coefficient of thermal expansion for steel and copper, as 12 into 10 power minus 6 per degree Celsius and 18 into 10 power minus 6 per degree Celsius respectively. So let us take this problem. In this problem, diameter of steel rod which is given as 20 mm. Then we have to find out the area of steel rod, and then area of copper tube which is hollow tube. So the major diameter is 50 and minor diameter is 40. Then you easily find out the area of copper tube. Then rise in temperature is given as T equal to 50 degrees Celsius. Then E for steel, that is given in giganewton per meter squared. Here I clearly told you that anything first initially we have convert into meter squared, that is millimeter squared, and then Newton, that is kilonewton into Newton. So here the value is given in 200 giganewton per meter squared. So you know that giga 10 power 9 Newton per meter squared. Then you know that 1 megapascal, that is 10 power 6 Newton per meter squared equal to 1 Newton per millimeter squared. Therefore here giga, which is only 10 power 3 higher than the mega, therefore which is 200 into 10 power 3 Newton per millimeter squared. Similarly, E for copper also 100 giganewton per meter squared, which is 100 into 10 power 3 Newton per millimeter squared. Then alpha values was given. So in this problem, the alpha for, that is coefficient of thermal expansion of copper, is more than that of steel. Hence the free expansion of copper will be more than that of steel when there is a rise in temperature. So clearly note that when there is a rise in temperature, copper have more elongation or more extension than steel rod. Okay, but the ends of the rod and the tube is fixed to the rigid plates and the nuts are tightened on the projected parts of the rod. Hence the two members are not free to expand. So whenever there have a restriction, definitely there have a stress. Hence, the tube and the rod will expand by the same amount. Therefore, the free expansion of the copper tube will be more than the common expansion, whereas the free expansion of the copper tube will be more than the common expansion. Hence, the copper tube will be subjected to compressive stress and the steel rod will be subjected to tensile stress. So, tensile load on steel equal to compressive load on copper for equilibrium of the system. Therefore, sigma S into AS, that is load. You know that sigma equal to P by A. Now, P equal to sigma into A. That is sigma S into AS equal to sigma C into AC. Therefore, sigma S equal to this much of sigma C. So what we have to do? So that is first condition. The next condition is the copper tube and steel rod will actually expand by the same amount. Therefore, actual expansion of steel equal to actual expansion of copper. Okay. Here, actual expansion of steel is free expansion of steel plus expansion due to tensile stress in steel, which is free expansion of steel due to temperature is alpha TL for steel, alpha S into temperature into length of steel rod plus expansion due to tensile stresses sigma S by ES into L, that is for finding del L. Okay. And actual expansion of copper equal to free expansion of copper minus contraction due to compressive stress in copper tube. So what happened? Compression or contraction means we have a separation. So for free expansion alpha C into TL minus contraction elongation, that is sigma C by EC into L. Then this is condition 2. So we can equate both uh, extensions of steel and copper. Then see here, sigma S into TL plus sigma S by EC into L equal to sigma S TL minus sigma C EC into L. So what are the values which are relevant? You take it on left side and you can put the values with respect to the given alphabets. Then you find out the unknown sigma C as 14.117 Newton per millimeter squared. Then for equation 1 that is sigma S equal to 2.25 sigma C. So that is the sigma C is 14.117 into 2.25. Then you can get stress at steel rod equal to 31.76 Newton per millimeter squared.